Hello again. So we are going to now do volume. So volume is always going to be in cubic units. So your units are now going to be cubed. And there's a pretty good reason why that is, and we'll get into that in a second. So first of all, we're going to describe the bases in a different way for volume in order to identify the bases versus the lateral. So the bases are congruent in prisms and in cylinders actually, and they're parallel. Okay, and what you can describe them as is they are the layers that make up the three-dimensional shape. Okay, when you are doing the volume of a prism, you've probably done the volume of just a plain box before, where you just do length times width times height. We're going to generalize that so that it works for other types of prisms. So the general formula is that volume is equal to the base area times that perpendicular height of the three-dimensional figure. So base area is in squared units, height is in linear units, but when you do squared units times linear units, that's where you get the units cubed. Okay, so looking at our first rectangular prism, when you have a rectangular prism, it actually doesn't matter which face you choose as a base, because any pair of faces are going to be congruent and parallel. So I'm just going to pick the one that it's sitting on. So this guy at the bottom, I'm going to choose as the base. So here you can see the base is 24 by 20. So first thing you want to do is get the base area. So I simply do 24 times 20. So that is going to be 480 centimeters squared. Okay, with that as my base, 10 centimeters would be the height. Let's separate this off. So the volume is the base area. So 480 is the base area, and then times the height of the prism. And so when I multiply those, I get 4,800. And again, this is going to be in centimeters cubed. Okay, so rectangular prisms are fairly straightforward. When it gets harder when you start putting in different types of prisms. So here, as you can see, you have 3 rectangles and then 2 triangles. Keeping in mind that your bases are congruent and parallel, well, none of these rectangles are parallel to each other, they all intersect. So the parallel faces would be the triangles. So let me do it with a highlighter. So this triangle here is one of the bases. Okay, and then this triangle would be the other base. They are congruent and they are parallel. Now what you can visualize is the base is also like a layer of the figure. So these are 10 inches. So you can imagine 10 layers of those triangles would make up the figure. So 10 of these triangles stacked together would make up that three-dimensional prism. Okay, so to figure out the base area, cut this one off. So the base area is that equilateral triangle. Well, equilateral triangle is 1/2 base length times the perpendicular height. Well, we need to figure out that perpendicular height, and we are going to use a 30, 60, 90 to do that. So remember, in an equilateral triangle, you can figure out the perpendicular height by using half the side length times √3. So that height is going to be 4√3. We did that quite a few times in chapter 10. So 1/2 base length here is 8, and then the perpendicular height 4√3. So that's going to be 4 times 4√3, which is 16√3, and that is inches squared. Okay, the height in this case is basically the number of layers of triangles. Well, you would need 10 layers of triangles, so the height would be 10. Okay, volume, you just put those things together. So the base area, 16 root 3, and then times the height is 10. So here we get 160 root 3, and that would be inches cubed. Okay, next one here. So again, you have 3 rectangles and 2 triangles. And again, the triangles are the ones that are parallel and congruent. So the triangle is the base. And then you have to visually think about what the height of the prism is after that. But I'm going to give you a second to try that one on your own. So pause and try to find the volume. Okay, so welcome back. You would have to do 1/2 this triangle with the right angle. This 6 is the base, and the 10 is the height of the triangle here. So I'm going to be doing 6 times 10. Okay, so that's going to be 3 times 10, which is 30 meters squared. So there's my base area. Now the height again is how many layers of that triangle do I need to form the prism? And I need 5 layers. So 5 meters is the volume, or sorry, is the height. So last, the volume, you do base area times that height. And so in this case, I get 150 meters cubed. Okay, next one. So cylinder, you're going to use the same kind of logic, except now the base is a circle. So the volume formula for a cylinder is still going to be base area, but the base is always a circle. So we just say pi r squared and then times the height. This is your base, or capital B, and then you times it by the number of layers of circles. Okay, so looking at number 1 here, let me cut this off. So base area is pi, and then radius is 3 squared, so that's going to be 9 pi. And then height, so I would need 8 layers of circles, so my height is 8 centimeters, and that's centimeters squared. Okay, volume, base area is 9 pi, and then times the height. So 9 times 8 is 72 pi, and that is centimeters cubed. Okay, on the next one, this guy is considered an oblique cylinder, so it's leaning, but you are still going to look for a right angle. So you're looking for that perpendicular height. So 3 is still going to be the perpendicular height. And then just be careful here because you are given the diameters too. But our formula needs a radius, and so that's going to be 1 meter. Okay, so you're still going to figure out the base area. We talked about the height already. So pause and find this volume. So here you're going to do pi r squared. So that's just simply 1 pi and then meters squared. And then volume is that base area times the height we said was 3. And so 1 times 3 is simply 3 pi meters cubed. Okay, so those are the basics. This last one here is a challenge. This is actually a very tough question, but we're just going to talk about it as a challenge. So this is optional. You can stop now if you'd like to, or I can go through this with you. So here what you can see is this aquarium is made up of sort of a boxy part here on the left, and then looks like a half cylinder part on the right. So we're going to cut it off to separate those two shapes. So I have half a cylinder on the right here, and then what is a prism, but looks like a box on the left. So what dimension we're missing is the radius for this. And what we're going to do is use this 24 to help us figure out the radius. So the radius should be in the middle here. And if all the way across is 24, so in other words, the diameter is 24, then the radius should be 12. Now, the cool thing about that, so that's 12, we could also draw the 12 going this direction. That is 12. So that is what this part is as well. That's 12. What that allows us to do is figure out this other dimension of the box. So if all the way across the aquarium, including both pieces, is 48, and we know the radius is 12, then the remaining part of this box is going to be 36 inches. So what that does is allow us to split this into two different problems. So the prism, the base area is going to be 36 by, and then that piece here is 12. So the volume is 36 times 20. Sorry, if I said 12, I meant 24. 36 times 24, and then the height here is 24. Okay, so when you multiply all of that together, it's a huge number. It's 20,736 inches cubed. Okay, so that's for the prism. And then you also need to do the cylinder. So I know this is a little bit crammed. There's not a lot of space here. But the cylinder is actually a half of a cylinder. So I'm going to put a half in front of it. It's half of a cylinder. But you're still going to do the same formula. So the volume of the cylinder is going to be the circle, so pi r squared, times the height here, we know is 24. And then you're just going to divide that in 2. So when you throw this in a calculator, you're doing 12 squared times 24 divided by 2. And you get 1,728, and then you still have the pi inches cubed. So then you're going to do a grand total, and the grand total is going to involve this plus this. So when you add those together, you get roughly, and you have to multiply by pi on this part, roughly 26,165 inches cubed as your final answer. So that is a little application, a much more difficult problem. Thanks for staying with me if you did. Okay, we'll see you next time.